Hello viewers, in today's class we are going to solve one important definite integral involving greatest integer function, right? So here we have uh, the integral from 0 to log of 3 and greatest integer 1 plus e raised to x, right? So let us start. So let us first call this integral as I, right? So let us make use of the method of substitution and let t is equal to 1 plus e raised to x, right? So therefore dt over dx is equal to e raised to x, and from here e raised to x is equal to t minus 1, right? So this is t minus 1. So therefore dt over t minus 1 is equal to dx, right? Okay, so this is the first relation, right? So now here x varies from 0 to log of 3, so let us change the limits accordingly, right? So what we will do, we will change the limits. So when x is 0, then the value of t is equal to 1 plus e raised to 0, right? So here we'll put the value of x equal to 0, right? So this is 1 plus 1 equal to 2. E raised to 0 is equal to 1. E is the exponential number, right? Now when x is equal to log of 3, this is the natural log, so t is equal to 1 plus e raised to log of 3, and e raised to log of 3 is 3, so this is 1 plus 3, that is 4, right? Okay, so here we have used the result that e raised to log of p is equal to p, right? Okay, so now we have changed the variable x to t, and we have also changed the limits, right? So when x varies from 0 to log of 3, 0 to log of 3, then t varies from 2 to 4, right? 2 to 4. Okay, so now we can represent this integral as I is equal to integral from t is equal to 2 to t is equal to 4, and here we have greatest integer t, because 1 plus e raised to x is t, and for dx we can write dt over t minus 1, right? Okay, so now we can make use of the definition of greatest integer function. So see here t varies from 2 to 4, so this is t is equal to 2 and this is t is equal to 4, and in between 2 and 4 we have the integer 3, right? So now we'll split this integral into two integrals, one from 2 to 3, other is from t equal to 3 to t equal to 4, right? So we can write first integral from 2 to 3, greatest integer t over t minus 1 dt, plus the second integral is from 3 to 4, greatest integer t and t minus 1 dt, right? So now let us make use of the definition of greatest integer function. So when t lies between 2 and 3, right, then the value of greatest integer t is simply 2, right? And when t lies between 3 and 4, then the value of greatest integer t is equal to 3, right? So in the next step what we will do, we have the integral from 2 to 3, so for this greatest integer t we can write 2, so we have 2 over t minus 1 dt plus 3 to 4, and for this greatest integer t we have 3, right? So 3 over t minus 1 dt, right? Okay, so now we have two simple integrals, so we can write, taking 2 outside this integral sign, we have integral from 2 to 3 dt over t minus 1 plus taking this 3 outside the integral sign, so we have 3 to 4 dt over t minus 1, right? So now we know that the integral of dy over y minus a is equal to log of y minus a, right? So we'll make use of this rule here, right? So now we can write 2 times of the integral of 1 over t minus 1 is log of t minus 1, and the limits are from 2 to 3. Then we have 3 times integral of 1 over t minus 1 is log of t minus 1, and the limits are from 3 to 4, right? Okay, so now we'll simply substitute the limits here and we'll take the difference. So I is equal to 2 times, so here we have log of 3 minus 1, that is 2, minus, will have t equal to 2, 2 minus 1, that is 1, so log of 1, and then we have plus 3 times here t equal to 4, so 4 minus 1 is log of 3, minus, here we'll have t equal to 3, so 3 minus 1 is log of 2, right? So now we can easily simplify this expression, so we have 2 times of log of 2 minus, see, log of 1 is 0, so we'll omit this term, so we have simply 2 times log of 2, then we have plus 3 times log of 3, and then we have 3 times log of 2. Now 2 log 2 minus 3 log 2 is minus log of 2, and here we have 3 times log of 3, and we can write log of 2 plus log of 3 raised to 3, because log of n log m is equal to log of m raised to n, and this is minus log of 2 plus log of 27, because 3 cube is 27, and now this expression is log of 27 over 2, because log of m minus log of n is equal to log of m over n, right? So the final result of this integral is log of 27 over 2, which can also be written as log of 13.5, right? So this is the value of this integral.